velocity gradient. It is defined as the ratio of change in velocity to perpendicular distance between adjacent layers of flowing liquid. Whenever we have the term gradient, it means that some physical quantity is being changed with the distance. So this distance may be the horizontal, this may be the vertical. When we are studying the velocity gradient of the flowing liquid, then in the streamline flow it has the different layers which are in contact with each other, but they do not intersect and they have the change in velocity. So as we go from upper layer to the lowest layer, there is a change in velocity. Now this velocity decreases from upper to lower layer. So this change in velocity with the perpendicular distance between the adjacent layers, that is called the velocity gradient. So now this is the upper layer. And there are so many layers here. This is now suppose ground. We can have the flow of the river flow like this. So now the velocity of this one is equal to v, and its velocity is v minus delta v. Then this distance is now from here, this is the distance z, and this is now distance z plus delta z. So distance between these two adjacent layers is delta z. So now we measure the distance from the ground. Suppose there is a river which is flowing, then the lowest layer of the liquid of the water that will be in contact with the ground. So the height is taken from the lowest point. So now height of this layer is z and height of this one is z plus delta z. So now distance between the two adjacent layers is delta z. The change in velocity is how much? Delta v. So velocity gradient is equal to delta v upon delta z. Unit is per second. Second minus 1, or the dimensions m0, l0, t minus 1. So its unit is similar to the unit of the frequency. The unit of velocity gradient is similar to the unit of frequency. Now this velocity gradient plays an important role when we find the viscous force between the layers. Of liquid is calculated. For example, you can have the Newton's law of viscosity. Viscosity, the F is equal to eta A delta V upon delta Z. So when we know the area of the layer, and the velocity gradient and the coefficient of viscosity, then we can find that what will be the viscous force. So whenever we study the change in velocity with the perpendicular distance, then we have the velocity gradient. So this is about the velocity gradient. Thank you very much.